Hello and welcome everybody to another episode of Books and Bytes. Today we're diving deep into coders at work. Peter Seibel's collection of interviews with 15 accomplished programmers.
Yeah, it's really like a backstage pass to the world of software creation.
Yeah, it is. So before we get into the specifics, what are some of the main themes you picked up from the book as a whole?
Well, one striking theme is the diversity of paths to success in programming.
Okay.
Some of these folks have PhDs in computer science. Others are self-taught.
Interesting.
Some thrived in large corporations, while others found their groove in the open source world. There's no single mold for a great programmer.
That's encouraging. So it's more about passion and a certain way of thinking than a specific background.
Exactly. Another theme that resonated with me is the evolution of programming itself.
Mm-hmm.
The book captures how the field has changed over decades, with languages becoming more powerful and the problems tackled by software becoming more complex.
Yeah, and I imagine that ties into a third theme, which is the importance of continuous learning. Technology doesn't stand still, so neither can a programmer.
Absolutely. Many of the interviewees stress the need to stay curious, to keep exploring new languages and technologies, and to always be pushing their boundaries.
So to summarize, we have diverse paths to success, the evolution of programming as a field, and the absolute necessity of continuous learning. Now I'm itching to dive into the individual stories. Where should we start?
Let's begin with Brendan Eich, the creator of JavaScript.
Yeah.
His story really embodies that rapid evolution we were talking about. Imagine having to create a programming language in just 10 days.
10 days. That sounds intense. What were the key takeaways from his interview?
Well, you might be surprised to learn that Eich actually defends some of JavaScript's quirks.
Huh.
He even refers to it as a blue-collar language designed for practicality and speed of development rather than absolute elegance.
So given the time constraint, it was more important to get something functional out there than to achieve theoretical perfection.
Precisely.
Yeah.
And he talks about the trade-offs you sometimes have to make when designing a language balancing expressiveness with accessibility for a wider range of programmers.
That reminds me of something Joshua Block, author of Effective Java, talks about later in the book. He emphasizes the importance of API design, especially considering how your code will be used by others.
That's a great connection. Both Eich and Block grapple with the balance between creating something powerful and making it usable. And speaking of usability, Block uses a clever analogy to describe learning new languages.
Okay.
He compares it to choosing a bar.
Okay.
It's not just about the drinks.
Yeah.
It's about the community and the vibe.
So just like a good bar, a programming language needs a thriving ecosystem and a sense of community around it. That leads us perfectly into Brad Fitzpatrick, the creator of LiveJournal and Memcached, who's deeply involved in the open source world.
Fitzpatrick really stresses the importance of designing for scalability, especially after dealing with LiveJournal's explosive growth. He emphasizes that building it right the first time is far easier than trying to fix things later on when millions of users are relying on your service.
That sounds like a hard-won lesson. Did he offer any advice for self-taught programmers given his own background?
Absolutely. Fitzpatrick champions constantly pushing your boundaries by always trying to do something a little harder that's outside your reach.
Okay.
He also stresses the importance of reading other people's code, contributing to open source projects, and engaging in dialogue with more experienced programmers.
So active learning, putting yourself out there, and being part of a community are all essential. Now, speaking of challenging assumptions, let's move on to Douglas Crockford, the advocate for JavaScript, the good parts. I've heard he has some strong opinions about coding style.
He certainly does. Crockford is a champion of clear, readable code. In his words, good code is elegant code. He emphasizes consistent style, meaningful variable names, and constant refactoring to improve clarity.
That makes sense. Code isn't just for computers to read, it's for other programmers to understand, maintain, and possibly even admire. I remember that Jamie Zawinski's interview touched upon that too, the importance of tools, but also recognizing their limitations.
Ah, yes. Zawinski's famous line about debugging a Lisp system, where he realized not only is the map wrong, but the tools are broken. It really highlights the ingenuity and resourcefulness required in those early days of software development.
So back then, you couldn't always rely on pre-built solutions and had to really understand the systems you were working with. Speaking of deep system knowledge, let's talk about Ken Thompson, the co-creator of Unix and the C programming language. That's a legend right there.
Absolutely. What struck me about Thompson's interview was his focus on simplicity. He believes that in most cases, a straightforward brute force solution is perfectly adequate.
So no need to overcomplicate things.
Exactly. He also cautions against spending too much time on premature optimization, especially with the constant advancements in computer hardware.
That's a good point. Sometimes it's better to get a working solution out there and then optimize if needed, rather than getting bogged down in trying to squeeze out every last bit of performance from the start.
Precisely. And he advocates for a flexible approach to code ownership, where responsibility can shift organically depending on who's actively working on a particular piece of code.
Speaking of taking ownership and challenging the status quo, let's move on to Fran Allen, a pioneer in compiler optimization and a strong voice on the impact of programming languages.
Allen's perspective is fascinating because she argues that the widespread use of C, while initially a good choice for specific tasks like operating system kernels, has actually hindered progress in areas like automatic optimization and parallelization.
So a language that was revolutionary in its time might be holding us back in certain ways today.
That's her argument, and it's based on her deep understanding of compiler technology. She believes we've lost ground compared to languages like Fortran and Lisp in some areas.
It's a reminder that even the most successful technologies have limitations, and that progress sometimes requires challenging established paradigms.
Absolutely. Now, on a slightly different note, let's delve into the world of Bernie Kosel, the master debugger who worked on the ARPANET's MPs.
I've heard he had some unorthodox but effective debugging techniques. What did you glean from his interview?
Kosel believed in thoroughly understanding the problem before even attempting to fix it.
Oh.
His methods often involve rewriting code he didn't fully grasp,
Wow.
a bold strategy that yielded surprisingly good results. He emphasizes the importance of code clarity, arguing that if you're struggling to debug your own code for weeks and someone else can fix it in minutes, there's likely a problem with your coding practices.
So writing clear, understandable code isn't just about good manners. It's about saving yourself headaches down the line. And I imagine that ties into his approach to legacy code as well.
Yes. Kosel advocated for a gradual, iterative approach to improving legacy systems, balancing bug fixes with incremental steps towards a better design.
That sounds like a pragmatic way to deal with the realities of working on large, complex systems where you can't just start from scratch.
Exactly. Now, for a contrasting approach, let's turn to Donald Knuth, the author of The Art of Computer Programming and the creator of TeX. He takes a very methodical, almost mathematical approach to programming.
Knuth is a legend. His books are practically sacred texts for many programmers. What makes his perspective unique?
Well, Knuth is a champion of literate programming,
Okay.
writing code that's as clear and well-structured as a well-written book. He even used his own CWEBB system to achieve this, and famously wrote the entire text program in pencil before typing it into the computer.
Wow.
Talk about attention to detail.
That's incredible dedication to his craft. It sounds like he sees programming as an art form in itself.
Absolutely. And he views understanding algorithms and data structures as crucial for writing good code, almost like a mathematician seeing them as the building blocks of his proofs.
Now, given his meticulous approach, I'm curious about his views on code reuse. Did he encourage programmers to leverage existing libraries or write everything from scratch?
Actually, he leans towards writing code from scratch. He argues it's often more efficient and enjoyable to create your own solutions rather than trying to adapt existing libraries.
That's interesting. I wonder if that approach will be feasible in today's fast-paced development environment, where speed and efficiency are often prioritized. Maybe we'll get some contrasting views from other interviewees.
Perhaps. But his point about potentially hidden flaws, even in widely used libraries, is worth considering.
Right.
He discovered a bug in the standard Java binary search implementation, highlighting that sometimes even the most trusted resources can have issues.
That's a good reminder to never blindly trust any piece of code, no matter how widely used it is. You always need to understand what's going on under the hood, especially when dealing with critical systems.
Exactly. And his rigorous approach to testing, creating torture tests to expose any weaknesses, is a great example of that mindset.
So forget being the proud parent of your code and become its harshest critic. That sounds like a good mantra for any programmer.
Speaking of taking a critical look at things, let's move on to Guy Steele, the co-creator of Scheme and a contributor to the Java language specification. He's seen the evolution of programming from the era of punch cards to the complexity of modern software.
That's quite a journey. What are some of his key insights from witnessing those shifts?
Steele observes that in the early days, you could understand everything happening within a computer. Today, with the sheer complexity of software systems, that's simply impossible.
It makes you appreciate the need for good abstractions and design principles to manage that level of complexity.
Absolutely. He also emphasizes the need for clarity and readability in code, not just for machines, but for other programmers who might need to work with it in the future.
So clear communication is key, both with the computer and with your fellow programmers.
Precisely. And even though he admits to being lazy and often relying on simple print statements for debugging, he acknowledges the power of more sophisticated techniques like symbolic debuggers and formal proofs.
And speaking of finding bugs, he shares a valuable lesson about always being on the lookout for multiple problems. Like he said, if you see one cockroach, there are probably more hiding somewhere.
A great analogy, it highlights that when dealing with complex systems, a single bug is often a symptom of deeper issues.
That's a good point to pause on for now. We've covered a lot of ground from the rapid-fire development of JavaScript to the meticulous craft of literate programming.
Indeed. And we've only just scratched the surface of the insights contained in Coders at Work.
Stay tuned for part 2, where we'll delve into the remaining interviews and uncover even more fascinating perspectives on the art and science of programming.
Welcome back to our deep dive into Coders at Work. We left off discussing Guy Steele's observation that modern software systems have reached a level of complexity where it's nearly impossible to understand everything that's happening.
Yeah, it's a humbling thought, isn't it? That even with all our advances in technology, there's still a level of mystery and complexity that we grapple with.
Absolutely. It highlights the need for constant learning, adaptability, and collaboration. Speaking of which, let's move on to Dan Ingalls, a key figure behind Smalltalk and a pioneer in object-oriented programming. He brings a refreshing perspective on making programming accessible and emphasizing the joy of exploration.
I'm always intrigued by approaches that focus on making programming less intimidating and more engaging. What did Ingalls highlight in his interview?
He advocates for a learning by doing approach, encouraging programmers to dive deep into areas that genuinely interest them, whether it's text processing, graphics, or music. He believes that anyone can learn to program if they have the right tools and motivation.
It's about tapping into that innate curiosity and finding the spark that ignites a passion for programming. Did he share any personal experiences that illustrate this approach?
Yes. He talked about developing the bit belt operation, a fundamental building block for graphical user interfaces. It's a great example of how a powerful idea born from exploration and experimentation can lead to a significant breakthrough in software development.
So sometimes a deep dive into a specific area can yield insights that have broader applications. It reminds me of something Fitzpatrick mentioned about not taking abstractions for granted and understanding what's happening under the hood.
That's a great connection. Both Ingalls and Fitzpatrick emphasize the importance of understanding the foundations even as we build upon them. And Ingalls acknowledges that while the increasing complexity of software might push programmers to work at higher levels of abstraction, there's still value in being able to delve into the lower level details when needed.
It's about striking that balance between leveraging powerful tools and understanding the underlying mechanisms. Now shifting gears a bit, let's hear about L. Peter Deutsch, the creator of Ghostscript, a widely used PostScript interpreter. I understand he has a rather unique perspective on the programmer's mindset.
He does indeed. Deutsch offers a somewhat provocative view, suggesting that being a truly great programmer might require a certain detachment from conventional social norms. He even goes so far as to say that there might be something a little wrong with you if you excel at programming.
That's certainly a bold statement. It challenges the romanticized image of the brilliant programmer as a social butterfly. But it also raises interesting questions about the kind of focus and dedication required to excel in this field.
It does, and it ties into the theme we've seen throughout Coders at Work about the different personality types and approaches that can lead to success in programming. There's no single mold.
It's about finding your own path and embracing your unique strengths and quirks. Now, beyond his provocative personality assessment, what technical insights did Deutsch offer?
He highlights the limitations of existing programming languages, particularly in their ability to handle information sharing and access in complex systems. He argues that we need new ways of thinking about software design, moving beyond the current focus on localized operations, like pointers.
So a call for a paradigm shift in how we approach software development.
Exactly. He believes we need new linguistic mechanisms to describe and control the larger patterns of information flow that emerge in complex systems. He's a big fan of Python for its readability and expressiveness, but he also sees the potential for merging the best features of different languages, such as combining Python with Smalltalk's powerful code generation engine.
It's that constant search for better tools and approaches that drives innovation in the field. Now let's move on to Yukihiro Matsumoto, the creator of Ruby. I've heard he brings a more humanistic touch to the conversation.
He certainly does. Mats emphasizes programmer happiness as a key design principle for Ruby. He believes that languages should be designed to make programmers' lives easier and more enjoyable, and that shines through in Ruby's elegant syntax and focus on convention over configuration.
It's about removing friction and allowing programmers to focus on the creative aspects of coding rather than getting bogged down in unnecessary complexity.
Exactly. He also highlights the importance of beauty in code, believing that beautiful code is easier to understand, maintain, and ultimately leads to better software. He'll even rewrite perfectly functional code just to make it more aesthetically pleasing.
That's an interesting perspective. It elevates coding to an art form where aesthetics play a role alongside functionality.
He also draws a connection between language design and culture, suggesting that programming languages are influenced by the cultures in which they are created, leading to different approaches to problem solving and software development.
That makes sense. Different cultures prioritize different values and approaches, and those values are bound to be reflected in the tools they create. Now let's shift gears again and talk about Donald Becker, the driving force behind Linux networking. He's known for his mastery of low-level optimization and his contributions to the open-source world.
Becker's work on network drivers was essential to the success of Linux, and he's deeply knowledgeable about the intricacies of hardware and software interaction. His interview dives into the details of optimizing network performance, offering valuable insights for anyone working with high-performance systems.
So a must-read for anyone who wants to understand the nuts and bolts of how networks function.
Absolutely. And his stories about the early days of Linux development highlight the power of community and collaboration in open source. He also cautions against premature optimization, emphasizing the importance of choosing the right tool for the job and focusing on simplicity and clarity.
It's a reminder that sometimes the simplest solution is the most effective, and that over-optimization can lead to unnecessary complexity. Now let's hear about John Bentley, the author of Programming Pearls and an expert in algorithm design and performance tuning.
Bentley's interview is a treasure trove of practical advice for programmers. He emphasizes the importance of understanding the problem thoroughly before jumping into coding, and his back-of-the-envelope calculations demonstrate the power of simple analysis.
So taking a step back to think things through before diving into code can save you time and effort in the long run.
Exactly, and he stresses the importance of choosing the right data structures and algorithms for the task at hand. His insights on making those choices are invaluable for any programmer who wants to write efficient and elegant code.
It's about having the right tools in your mental toolbox and knowing when to use them.
Precisely. And his stories from his time at Bell Labs, working with some of the brightest minds in computer science, offer a glimpse into the collaborative and intellectually stimulating environment that fostered so much innovation.
It's a reminder that surrounding yourself with brilliant people can push you to do your best work. Now let's explore the world of object-oriented programming with Tom Love, the co-creator of Objective-C.
Love's interview offers a fascinating look at the history and evolution of object-oriented programming. He initially had reservations about this approach, but his experience working on Smalltalk at Xerox PRR convinced him of its power and elegance.
So a classic case of initial skepticism turning into passionate advocacy.
Indeed. He also shares his insights on the challenges of balancing power and practicality in language design, which are valuable lessons for anyone interested in language creation. And his story about how Objective-C, initially adopted by NextT, eventually became the foundation for iOS and macOS development, is a reminder of how seemingly niche technologies can have a huge impact on the world.
It's a testament to the unpredictable nature of innovation and the power of good ideas to find their way into unexpected places. Now let's shift gears to another influential language designer, Anders Hallsberg, the chief architect of C#.
Hallsberg's interview is a masterclass in language design and implementation. He's passionate about creating languages that are both powerful and easy to use, striking a balance between expressiveness and simplicity.
That's a tough balance to achieve.
Yeah.
What specific lessons did he learn from his previous work on Turbo Pascal and Delphi?
He realized the importance of incorporating features that support large-scale software development, such as garbage collection type safety and modularity. These features help manage complexity and reduce the potential for errors.
So it's not just about creating a language that's elegant and fun to use, it's also about making it practical for building real-world systems.
Exactly. And he predicts a continued trend towards higher-level abstractions and domain-specific languages in the future, suggesting that programming will become increasingly specialized.
That makes sense. As software systems become more complex, we need more specialized tools to manage that complexity.
Now for our last interview before we wrap up part 2. Let's turn to David Hanson, the creator of Ruby on Rails. He's known for his strong opinions and his emphasis on developer happiness.
I'm always interested in hearing from people who challenge conventional wisdom and push the boundaries of what's considered best practice. What are some of Hanson's key tenets?
He's a strong advocate for convention over configuration, believing that frameworks should make sensible assumptions rather than requiring developers to specify every detail. He also champions rapid prototyping and iterative development, focusing on building working software quickly and refining it based on feedback.
So a more agile and pragmatic approach to software development.
Absolutely. And he stresses the importance of developer happiness, believing that programmers who enjoy their work are more productive and create better software. He encourages aspiring programmers to find a problem they're passionate about and just start building.
It's about finding that sweet spot where passion, practicality, and technical excellence intersect. Well, we've covered a lot of ground in this part of our deep dive into coders at work.
We've explored a wide range of perspectives, from the philosophical musings of L. Peter Deutsch to the pragmatic advice of John Bentley and the humanistic focus of Mats and David Hanson.
And we still have one more interview to discuss. Stay tuned for part 3, where we'll wrap up our exploration of this insightful book with a conversation that brings together many of the themes we've been exploring: clarity, simplicity, and a deep understanding of the fundamentals. Welcome back for the final part of our Coders at Work deep dive. It's been quite a journey hearing from so many talented programmers.
It really has. We've explored a wide range of perspectives on everything from language design to debugging techniques and the evolution of software development itself.
And now we've reached our final destination, Edsger Dijkstra, a figure who looms large in the world of computer science. You mentioned earlier that his interview brings together many of the themes we've been exploring.
That's right. Dijkstra was known for his rigorous approach to programming, his advocacy for structured programming and formal verification, and his emphasis on clarity and mathematical thinking.
So a true pioneer who laid the groundwork for many of the practices we consider standard today.
Absolutely. He believed that programming should be treated as a rigorous intellectual discipline, akin to applied mathematics.
And he didn't shy away from expressing that view quite strongly, did he? I recall his famous quote, "Programming is one of the most difficult branches of applied mathematics. The poorer mathematicians had better remain pure mathematicians."
That's the one. It reflects his deep conviction that programming is about much more than just writing code. It's about thinking deeply about the problem you're trying to solve and designing a solution that is both correct and elegant.
And his work certainly embodies that philosophy. His algorithms, like Dijkstra's shortest path algorithm, are still widely used today, and his writings on topics like concurrency and program correctness continued to be influential.
He was also a strong advocate for the use of formal methods in software development, believing that mathematical proofs could be used to verify the correctness of programs and eliminate bugs.
Which seems like a very logical approach, especially as software systems become increasingly complex and critical. We can't afford to have bugs in systems that control airplanes or medical devices.
Exactly. And Dijkstra saw this coming decades ago. He was ahead of his time in many ways.
One thing that struck me about his interview was his emphasis on clear thinking and precise language. He seemed to believe that sloppy thinking leads to sloppy code.
That's a great observation. He was a stickler for using concise and unambiguous language, both in his code and in his writing. He saw a direct connection between clarity of thought and the quality of the resulting software.
So it's not just about what you say, but how you say it. Precision and clarity are essential.
He also had some interesting thoughts on the nature of programming and the role of the programmer. He saw it as a creative activity, but one that required discipline and rigor.
It's that blend of art and science that makes programming so fascinating, isn't it?
Absolutely. And he believed that programmers should strive to create programs that are not only correct, but also beautiful.
That's an intriguing concept. The idea that code can have aesthetic qualities as well as functional ones. It reminds me of Matz's emphasis on beautiful code in Ruby.
That's a great connection. Both Dijkstra and Matz saw programming as a craft that could be elevated to an art form.
Dijkstra also had strong opinions about programming education. He felt that too much emphasis was placed on syntax and specific technologies rather than on fundamental principles.
He advocated for a more rigorous approach to education, one that focused on teaching students how to think critically and solve problems systematically. He wanted to equip them with the mental tools to tackle any programming challenge, regardless of the specific language or technology.
That's a valuable lesson. The fundamentals are always relevant, even as technologies change and evolve.
Well, I think we've come full circle. Dijkstra's interview serves as a fitting conclusion to our exploration of coders at work. It brings together many of the themes we've encountered throughout the book. The importance of clear thinking, elegant design, rigorous testing, and a deep understanding of the fundamentals.
It's been an incredible journey, hearing from so many brilliant minds and diverse perspectives. I feel like I've gained a deeper appreciation for the craft of programming and the people who dedicate their lives to it.
Me too. It's a reminder that programming is more than just a job. It's a creative pursuit, a problem-solving challenge, and a constantly evolving field that pushes us to think differently and to create innovative solutions.
So what are the key takeaways you hope our listeners will walk away with from this deep dive?
I think the biggest takeaway is that there's no one right way to be a programmer. The individuals featured in Coders at Work come from diverse backgrounds, have different personalities, and use different approaches to problem solving. What unites them is their passion for the craft, their dedication to quality, and their willingness to constantly learn and adapt.
And it's that willingness to learn and adapt that I think is crucial in today's rapidly changing technological landscape. We need to be lifelong learners, constantly expanding our knowledge and skills to stay ahead of the curve.
Absolutely. Coders at Work provides a glimpse into the minds of some of the most talented programmers of our time. It offers valuable insights into their thought processes, their approaches to problem solving, and their philosophies on software development. It's a book that can inspire, motivate, and challenge programmers of all levels.
Thank you for joining us on this deep dive into Coders at Work. We hope you've enjoyed the journey and that you've gained some valuable insights along the way.
And we encourage you to check out the book yourself, to delve deeper into the minds of these fascinating individuals.
Until next time, happy coding.